What's going on, y'all? Sean, the Master Tutoring here. And in this video, I want to talk about an easy way to look at surface areas of common shapes. Okay, I actually got a request for surface areas in the previous video I did. So hopefully this video helps to clear up how to look at surface areas. They're very easy, but they're often confused with, for example, volumes of shapes or like even just general surface area. So first of all, what is surface area? Surface area is basically just the area of the outer surface of a shape, a three-dimensional shape. Just the area. So think about this, especially since we have a cube up here. So say for example, we just wanted to know the area of this front face right here. That's just a square, okay? So the area of that is, of course, the area of a square is going to be length times width, but we know that that length and width are the same because the square has equal sides. So we're just going to call that S for side, S for side. So the area is, remember, area is two-dimensional, okay? So that means you have to essentially multiply two dimensions to get area. So that's why the area of this surface area is just side times side, or in other words, side squared. Now, that said, if we're talking about just the area of the outer surfaces, looking at this cube, we need to know um, what surfaces we're dealing with. There are six of these. Sorry, I didn't mean to draw that little curve. There are six of these. You have one here, you have one on the side, you have one here, you have one on the back, you have one here on this side that's hidden, and then you have one underneath. So that means you have six total sides, all of which have an area of s squared. Therefore, the area of a cube is equal to 6 times side squared. Okay? Very, very easy. Remember, surface area is just the outer surface of a three-dimensional shape. All right? So, what about this? I guess it can be referred to as a cuboid or, just a rectangular prism, whatever you want to call it. What about an area of this similar to a cube, but we know that all the sides aren't necessarily equal. But check this out. We have six surfaces. Then you have, out of those six surfaces, you have four rectangles and you have two squares. So you have one, two, three, the one in the back, the one underneath, and then this one hidden right here. Okay. Now, the four rectangles all have equal measurement, so they all are going to be like this. So, we'll say, um, we'll call this height and we'll call this length. Okay. Now, so you have six of these, and then you have the square. Now, if this is height, realize that this is the same thing as this right here. So I'm not necessarily going to name this the way people usually do, but I'm just trying to make sure it's clear what um, sides coincide with each other. So I'm just going to be consistent with what I'm using here for the rectangle. So because these are squares on the sides, then it's really height squared. So you basically have 2 times height squared, and then here you have 4 times the length times the height. So therefore, the area of this rectangular prism ends up being 4 times length times height plus 2 times the height squared. Okay, that's what that is. So if you know those measurements, then you can very easily find the surface area. So I said A, so I should call this SA, so nobody gets confused. I should have did that in the previous slide, but just know that. Okay. Now you may want to do something like this: to say the surface area is equal to reverse distributive property. You might want to do 2 times the height plus the 2 times the length plus height. Okay, I don't know, but it's the same thing. 4 times length times height plus 2 times the height squared. All right. Another common shape is a cylinder. Now let's keep in mind what a cylinder is. A cylinder is basically, if you think about it, if we were to slice this down the middle, you would see that this is basically a rectangle plus a circle up top plus a circle on the bottom, right? Now, first of all, just to go back, we know that the area of a circle is pi radius squared. So these each have a radius, okay? And so this pi r squared, right? This is the radius, I'll say right here. Now keep in mind this is a height of some sort. So height, this is h for the rectangle. The question is, what is this dimension right here? If you look at this and realize that it comes around those circles at the top and the bottom, this is going to be equal to the circumference of the circle, 2 pi r. Okay? Because it's literally the outer rim of the circles that comprises the length of the top of this rectangle times that dimension of h. So what is the area of this rectangle? It's going to be 2 pi r times h, okay, plus, and then you have pi r squared plus pi r squared. That's the surface area, okay? So surface area of a cylinder is the area of this rectangle, which is 2 pi r h, plus the area of this circle, which is pi r squared, plus the area of this circle, which is pi r squared. So if we want to clean that up, we can say the surface area equals 2 pi r h plus 2 pi r squared, right? If you want to clean it up or make it look a little bit neater, you could say it's 2 pi r times h plus r, right? Yeah. So there you go. If you can visualize, you can say, oh, yeah, this is all this is. Just kind of break it up into its constituent parts. Okay, now let's look at surface area for a cone. So let's break this one down into what it actually comprises of. This is a circular base with some radius r, as well as the cone part, if you will. Just imagine that we sliced this. This is the length, and I'm gonna put here a radius. Just imagine we sliced the cone there, then we kind of open it up. It would look something like this. Okay, with the length, what's called the slant height, actually. The length being here. What is the length here? This curved line? The length here is the circumference of that circle. Because remember, it goes around the circle. So the length here is going to be 2 pi and the radius of that circle. Length, if you keep in mind that this cone has a height, length is, this is a right triangle. You can use Pythagorean theorem to find what the length is. So the length is equal to the square root of the radius squared plus the height squared. Now, keep in mind that this kind of semicircle looking thing is a lot like a triangle. It has a um it has a the L this length here, and then it also has this base. Okay, so what happens is this ends up being, you remember the area of a triangle is 1/2 base times height. So what happens is this L ends up being a type of height for this triangle, and then you have the base, which is what this, even though it's curved, that's what this ends up being. So it ends up being 1/2 times 2 pi r times the length, which is r squared plus h squared. Those twos cancel, and so this ends up being pi times r times L, which is just r squared plus h squared, which means, again, remember the area of this is pi r squared. So the surface area of a cone is um, pi r squared plus pi r squared plus h squared. Or if you want to simplify that, it's pi r times r plus r squared h squared, the square root of that. Or if you just want to replace that with, if you knew the length of the cone, you could just say pi r times r plus L. Okay. So yeah, there you can go into more depth into like how that ends up being kind of like treated like a triangle, but that's what it ends up amounting to. But let me know if this video cleared stuff up for you. If you can kind of visualize surface area, which is the outside area of a shape, it's not the volume, which is like the a measurement of the whole entirety of the thing. It's just the outside. Let me know if this video helped you and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.